All right, we're back and we're on page 246 now. And you've probably been thinking like, what else can we do with these summations? Hopefully you've been trying to think that. It turns out that we can actually find areas of strange regions also. Like, so we've been taking weird things and rotating them. That's kind of the conceit. That's why we started doing this. And at the end of the last set of notes, we were rotating just lines. And when you rotate just lines, you get geometric figures that have well-established volume formulas, and you can just like use those to find the area, the volumes, I should say. If things are weird, you pretty much can't do that. But it turns out that you can just use cylinders, a lot of cylinders, an infinite number of cylinders, in fact, and you'll get the exact value. So we can do the same thing with areas. It's almost easier. And so the reason that we don't start with that is that people tend to underestimate how complicated things will get when things start out a little easy. So what I wanted to do is start out with something where you really have to kind of think it through. And now what we're going to do is we're just going to make the rectangles. We're not going to make a rectangle and rotate a rectangle. We're just going to make a rectangle. So on some of these, I'll probably change the way I talk about it. I'll talk about heights as going this way. For cylinders and rotating, the heights are always along the x-axis, which is also a safe way to think of this. I just like can't break the habit of thinking of the heights as being the vertical. So let's see. We want to write a summation that approximates the area of the region bounded by y equals x squared, x equals 1, x equals 4, and the y-axis. Use a summation and the given number of rectangles. So instead of volume, we're going to get area this time. I'm going to sketch it, just get an idea. I think like never be afraid to make a sketch of something because it can help clarify in your mind like what you're doing. So we got this. All right, let's say this is 4. Let's say this is 1. So go all the way up there. Okay. I'm going to take this, I'm going to divide it into equal parts. So let's just say I do 3 for example. And then I'm going to do basically the same thing, right? So I'm going to start at 1. I'm going to go over by delta x, which in this case we know delta x, right? It's 4 minus 1 divided by n. So for this, it would just be 1. Then I'm going to go up and then across and down. The area of that rectangle, so if this is delta x, the area of that rectangle is just going to be delta x, the base, times f of x sub 1, right? F of x sub 1 is, well, x sub 1 is definitely 2 because we're making 3, but that would be the area of that particular rectangle. Then I'm going to do it again. So I start here, I go over, up, over. So this is, again, delta x. So the area of that is going to be delta x, and then f of x sub 2. And then I'm going to do it again. I'm using this color. I go over, go up. This was a poor choice. I know they're different, but they're not like different enough. This. Okay, so this, delta x. So the area of that would be delta x, f of x sub 3. F of x sub 3 should be you start at 1, delta x is 1, you add it once, gets you to 2, add it again, it gets you to 3, add it again, it gets you to 4. It's always going to be that last value, so x sub 3 is actually 4 in this case. And I just want to add those up, right? So in general, because we want to do this in general, so delta x is going to be 4 minus 1 divided by n, 3 over n. Same idea. A lot of this is the same idea. X sub I is going to be where I start, which is 1 plus I delta x. Same idea. But in this case, we're finding areas. So the area as a function of n is going to be the sum from 1 to n, right? So we did 3 last time or in the example. So I went from 1 to 3. I'm going to go to 1 to n in general. It's just base times height, right? It's not pi r squared, or we're not rotating anything. We're just making a rectangle. So it's just the base, which is delta x. I'm going to write that last, actually, times the height. The height is f of x sub I. So f of x sub I, and delta x. In general, you want to get used to putting delta x at the very end because that's a big thing that you have to deal with. So now we want to use calculator. to find these values. And then while we're there, I'm probably just going to take the limit and see what I get. So switch over to a calculator. And I'm going to add a new problem again. All right, so f of x is x squared. And then my area as a function of n, so a of n, is going to be the sum. So this is like unquestionably easier to enter. From 1 to n of f of x sub I is, what is it? 3i over n, and then times 3 over n, right? So that's the height times the base. The base is delta x, which is 3 over n. Okay, so wait, this is wrong, because x sub I is 1 plus 3, because I started at 1, and then I'm going, so 1 plus. Okay, so that, let me delete this so you don't have to look at it. Hide your shame, that's what you want to do. All right, so if I do a of 2, I'm just going to do the things in the notes. A of 10. We got way smaller there. A of 100. Okay. A of 1,000. Okay, could we maybe say this is going to be 21? Maybe. Let me do a of 5,000 and see what this says. Ooh, it's getting closer and closer to 21. I'm going to say that the area of this is probably 21. Let's see what the actual area is. So to do that, we'll take the limit as n goes to infinity, which you should just use a pi key, faster for me to type, of a of n. We get exactly 21. So that's like really interesting that the exact value is 21. And as we increase the number, we get closer and closer. That's the limit, right? So the limit, the value that those approach, is 21. That's the exact value. There's no error involved there. We get exactly 21. I'm going to copy these down, which I probably should have done. So you should also copy this into the table. And then I don't really know how long this is, so I might stop there and come back and do some problems that are on the page. 2, 3, 2, 9, 5. I anticipate them going a little quicker, but mostly I gotta get myself to shut up and just like do the problems, you know? 21.0. I'm happy that you're all spending this much time with me. I wish I like knew what we were doing, but what you're doing, I mean, I hope you're taking notes. All right, so I'm gonna switch back to the notes for 1 second so you can just see what I did. And then we're done with this, and I will come back and do more in another video. And there you go. So I got them all filled in. Come back and do, I think, 3 of these problems. I'm going to save D for another video because that one requires a little more thought. So I will be back and I will see you. Well, really, you'll see me then. But either way, I hope you're finding these helpful.